I took C out because I want to keep C. So I just so then I was like, so D's on this one. So I just right, that's right. That's what I was saying. What else am I
It's funny now.
So I don't work until it's a little wet outside. And I think I'm kind of wet. This week, what is this?
Yeah, what?
Oh, why aren't we all? I'm gonna switch it.
Well, I guess we're all seeing.
You're just like that.
Yeah.
And those chairs.
Oh no, I can't name the song about it. I could name all of them. I don't know about their love. So we submit on my application. Wait, people are meeting? I would check my. Good for you, you're done. I'm still waiting. Okay, is there a, ooh, I don't know. It's a little bit. Just grab a white chair, maybe. Oh, no. Why am I not? Are you gonna sit? Me and Ian were 5 years. It's like jackpot. And like one of them was you have to list the stats of how many of us are you. 40% of people sit in a chair. That was one of the questions actually. Was how many percentage sit in a chair? How many are in? We kind of split, because we got the short. We don't really like things. Like we sat in this last time with those chairs, just have a bag.
I believe that's why.
Say we use it. I was way ahead. Way before. I'm sorry, there's something. This wasn't what I was. It's like my crafting space. I'm more scattered. You're just amused things. It's not fun.
Those back tables are open now. If you want to come across the screen, there are time to back tables are open for us. And where the side room.
Why don't we just do everyone that?
We are.
Yeah, I want one of their friends to say that everybody. You have a lot of stickers. A lot of stickers.
Yeah.
And all of these.
So many Canadian cafe problems. You're talking about like computers.
So you just sticker your computers? Yeah, I had a black phone case and my phone was stolen, so now I have a hot pink sparkly phone case. I'm like, try stealing that.
There's white markers up here.
Especially if it's like a guy that's like the hot pink sparkly phone. Oh my god. So, who was apparently the old Ben cannot be the doctor, so
All right, good evening, everyone.
yes, on Facebook.
All right, good evening, everyone. To start off the night, same as we normally do, meet with your teaching fellow groups and try to talk through any problems you had, specifically teaching fellows in Canvas in your inbox. I have some stuff there to go over. If you don't mind, one of them is specifically just like a brief, if you go over for like 5 minutes after you sort of take attendance, get used to everyone who's here, the truth tables. And if you don't know what truth tables are, that's fine, and then probably don't go over it. with your group, because then you and your group will be confused. But I will check back in about 15 minutes. 10 to 15, so everybody can sort of talk over. And your teaching fellow, if they are not here, raise your hand and I will sub in for them at the start. All right, so Tom's here, so Mike is not here yet. All right, I will sub in there. Alec is also not here yet. If Steve could cover Alec, that would be. Mike's here. Bam.
Hey, can we get access? Yeah, it's not due yet.
Yeah.
You can kill you.
Yeah, we can do that. This one. But if you notice my shift.
Digital.
It looks like this is
I didn't want to make yeah, so you do
So I got
No,
If you want to.
So, yes.
yes, there's four corners. I didn't realize that.
So a lot of times, people so this is just the habit.
Because there's 20, I'm turning it into
So it's not like
yeah.
I think it should be.
But I do that. I should be raised.
Yeah, he said. Hey, like I looked at it. Yeah. That's what I was. So you can take it out. So now, I did.
No. No, because it's right.
So for each assignment, you actually manage to have drive there. You are going to see.
I gotta switch them back and forth. No, it's gonna go. I'm gonna.
That's what it's all.
So that's
House.
So, yeah.
I did this. Right, I know, that's what I want to see that.
Okay, I don't like. That sounds like it was right. I'm not kidding. I have like I have $15.13 until Thursday. Did not be McDonald's. Slow, it's just basically I made it look.
One number, yes, or yes or no.
What number is it? Oh, wait. I forgot that. What? Yeah. Oh, no. That's not, I drive the circle. I'm not that bad. It's the lighting. I'm not. You've got to get your containing things right.
Was that loud? Too loud? If it starts to echo, let me know, and I'll turn down the volume. Yeah. All right, is everybody ready to start? I'll take that silence as a yes. You're supposed to can't do that. All right, did everyone have a chance to go over the reading? And I shared a link on Slack attempting, if you're in the back and you don't want to move forward or it's difficult to see, I put a link in our Hello KC Slack and hopefully I'm showing that. I am, good job. And did anyone get to look at truth tables for a few minutes? Was it exciting?
Yes.
Boolean logic is so much fun. And it's the reason most programs work, is because of it. So the three sort of main things to think about. I'll make this bigger. Is this big enough? I don't think I can make it much bigger and have enough on the screen. And can everyone see this on? So if you're using the YouTube live link, let me know if I'm scrolling too fast because there's a bit of a delay. And I don't want to make you lose it. That's not actually recording because I don't know how to make YouTube live record what's happening, or if that's an option. So these aren't recorded, they're just streamed. If you know a better way or a tool that is better, feel free to let me know. And then one administrative thing I meant to say at the start is that we should try to be here as the earliest time to be here is 5:45 because the space itself will not always be available at 5:30 because a lot of other events are planned and take place here. So they're going to stop letting us in early. 5:45 is the earliest they're going to let us in. And one of the reasons to not show up too early is it's going to start getting cold, and I don't want anyone to get sick or ill from standing outside in the cold for 20 minutes before you're able to come in. So try to make sure you're not here earlier than 5:45. So between 5:45 and 6 is ideal. Now onward to exciting Boolean expressions. So the three main things to take into account with the Boolean expressions is how operators between them work with and or if you try to do, Python will sometimes allow you to do things like multiply and add different types, and it may not do what you expect. You can play with that for fun. The number one thing around these expressions that matters is operator precedence. So if you're doing an if condition, you'll need to make sure that you remember the order of operations, that exponents are evaluated first, and that multiplication and division come next, and then where in that whole hierarchy each one of these operators, Boolean operators, and or and not, fall within that precedence. And there's that chart on python.org that shows the official operator precedence. There we go. So we haven't talked about lambda expressions, and we probably won't. So don't worry about this. But we have covered everything up through these in, not in, well, in. Not and, or, if, else, and lambda, and then operators for multiplication, division, which are down here, as well as plus and minus. You'll notice a few other operators that we have not covered, but this chart, which is available on the Python website, just search Python operator precedence in Google, like I just did. It's at the bottom of the page, and it shows from top to bottom what matters first and what is evaluated first. Something to know is that or has a higher precedence than and. So if you say true or false, I'll actually show this example here. So true and false is going to be false because if you have something that is true and something that is false, it will return a false value. The reason for that is because you have to have two things to be true in order for and to say that it is true. This example, so if you say true or false and false, it actually returned true, which might be confusing. And then if you do false and false, it returns false. And the piece to check specifically here to sort of see the main difference.
Or has a higher person?
Yes.
So how does that statement work? The true or false and false? The same value with true or false?
So true or false.
Yeah.
Because true or false. Right, so this is, ooh, let me, let me get back to the precedence chart. Yeah. That is correct. Yeah, I read that wrong. That's why you read the docs. Yeah, from lowest precedence to highest precedence. That's why you shouldn't trust anything I'm saying. If I show it to you on the screen, you should just assume that the screen is correct, that I'm not telling the truth. So to remove that confusion, and has higher precedence because this is in reverse order. So everything at the bottom comes first. And then you come to and, which is more important than or, which is more important than an if-else, and then lambda, which we haven't covered that. You can nest ifs with other Booleans, which is the reason that it mentions which ones take precedence. I'm not going to do that because that's generally not a great idea. That's why I'm not going to show it either. Don't want to encourage bad behavior. So Reggie, good catch on my lies. Yes, so the way that Python executes normally is what's here on the bottom because and is more important than or in the docs here. To zoom it in further, I think it was difficult to read what it was before. It's in reverse order. And so I could show you docs that are a little more succinct, but it is good to be comfortable with looking at the Python documentation directly whenever you're programming, because a lot of the times when you're writing something and it's not clear, the Python doc will have examples or even exact errors. So if you're using something like the math module or the turtle module and you have an error, a lot of the times the Python documentation will have an exact example there showing, oh, this is where you went wrong, which is, whenever I showed the initial turtle example, they showed an example of that error on the doc page itself. This is another example of where using parentheses to show your intent of how something is going to be resolved is important. So a lot of the times when you write code, having the parentheses in place, even if someone knew this is how it executed, having the parentheses tells whoever's reading that, yes, this is exactly what you intended. And that's good in general because a lot of people, when you're writing code, are going to be writing in more than one programming language. And these rules around or and whichever one coming first are not the same across programming languages, which is why I'm an advocate for turning off notifications in general. Just gonna close that, won't happen again. So having these parentheses in place tells your reader what your intention is with your code. If you don't have the parentheses in place, they have to assume what you meant is the operator precedence, which may or may not be the case. As you build a larger system, that you use the parentheses because you'll be using variables and not Boolean values, which I'll show later in a really awesome blackjack example, because I assume everyone is a gambler. You may not be, it's okay. The other thing is to notice how not basically reverses whatever you had before. So not false becomes true, and not true becomes false. So I will but to show what that happens, it reverses whatever expression you had. And the rules around how true and false can be anded together or ORed together or knotted and how they work can be sort of more easily visually seen. It's called if you use truth tables, which is why I mentioned it. You can see a diagram if you want to, so that the reason that this is easier is over time, if someone wrote a really complicated expression and it's hard to follow to determine where it is, if you just know that if you have a true and a false and they're anded together, it's false, then you can sort of eliminate paths of code as you're reading through it. So this Wikipedia page sort of shows how AND works. If you have two true values, it's true. If you have a true and a false, it's false. False and a true, it's false, and false and false, it is false. Or is true in every case except for both sides of your or are false. And that's why I linked directly to this page. And these links will be in here whenever I share it on the class. So I'm going to add it to the class notes like I did last time. And then this logical negation shows an example of if you have some variable and you say not that variable, true becomes false and false becomes true. I wanted to show this because it's not a concept that is unique to programming. It's just, in general, it's called logical expressions. And then to recover the unnecessarily complex factorial example I did last Thursday, where the function called the function, I had that for loop that made it really confusing. So if you have an if statement, this is an example when it's really helpful. What you say is, if whatever is passed in is 0, return 1. In all other cases, return whatever was passed in, and then call this function again with 1 less than that number. And then you end up with the same sort of output we had last time. Don't worry so much about the recursion. What I wanted to show is that once you start to have if statements and Boolean expressions, it makes your code a lot easier to read than the example from last week that had the for loop in that spot. I'll zoom that out so I can show. Yes. So last week, this example, sorry it took so long to pull up. From last week, it had this for loop, and it was difficult to sort of see how that worked. The exact same result happens with the code from today with just having the if statement here and then executing that, which is a lot easier to follow what happens as it executes. Don't worry so much about the recursive aspect, just note that the logic of what's occurring. So you're going over some range. I think that is more confusing than just saying if the number is 0, return 1, otherwise go and compute another number. Now, the next example that I'm going to cover is going to show the book hit on having functions that are what they call Boolean functions, that if you give them input, they go and tell you if something should happen. So is delivery driver, if you had a bunch of users in a system, you might do that to sort of segregate who in your system is a delivery driver versus someone who might stock trucks. For instance, if you were writing a program for UPS or FedEx, you might care about different roles of people, so that's where you would use Boolean functions to sort of test what each type of person is. So you can sort of put them in different groups in your HR system if you went and built one out. So this example is a not intelligent blackjack, playing blackjack. So not intelligent in that the strategy is hard-coded, but it is honestly very similar to how I play blackjack, which is why I don't gamble very often. So this function is here mostly so the game can be played. So it will be dealer will hit, which if you're unfamiliar with blackjack, it is a game you play with cards, a deck of cards, so 52 cards, and you get dealt a card face down and one face up. And the one face up sort of tells everyone what you could possibly have, and then you have one sort of a secret that other people cannot see. And the goal is to get to 21 or less, and you're playing against someone who's called a dealer. And if that dealer has a higher amount than you and hasn't gone above 21, at the end of the round, the dealer wins. You can tie if you have the same amount with the dealer, or you win if you have a higher total than the dealer, which I'll actually show below. It tests the win condition. So here is a basic if condition using the less than or equal to operator that it mentioned in the book. Thing to know is that whenever you're doing one of these something equal to operations, the less than or equal to or greater than or equal to, the equal always comes last. So it is easier whenever the program runs for Python to know what you mean in your expressions. So this will say if the dealer hits based on the cards value that are passed in. And because I'm lazy, I just added all the cards together and passed the whole value in. I don't pass individual cards in. The next one, this is the ultimate strategy for playing blackjack, the should I hit function, which will end up returning true or false based on what happens. And something to note here, so without reading all the logic, is the levels of indentation. So right here, you'll note it goes one level in. That says everything at this indentation level until I pop the next line of code not at that indentation level, which means everything from here all the way up through there. So everything I've highlighted is contained within should I hit. So that means when you call should I hit, all of this code potentially runs. So the next one that comes in here and hits this if statement, if this is true, then it will end up returning true immediately and it will stop executing. So inside a function, as soon as it hits its first return, it will no longer run any more code inside that function. Sort of like a stop sign that says, we're all done, go on to the next thing. So the part to take into account here, this is an example. So the book had mentioned having nested if conditions. So in this one, what I'm saying is if my cards are inclusive between 17 and 19, which means if my cards all added together are 17, 18, or 19, I'm going to check to see what the dealer is showing. So the dealer, I'm only going to see their first card. In blackjack, we'll have one that's face down. That first card could be anywhere a value of 1 to 10 showing. I simplified it. The ace is only worth 1 in my game of blackjack. It's not worth 11. To simplify running this. So what I'm saying here is, okay, if the dealer has less than 5, which would mean they have 1, 2, 3, or 4 showing, and I have a number that is greater than or equal to 17 or less than or equal to 19. And I did want to show an example that you can, if you remember writing sort of those math equations in elementary school around what's greater than or less than, Python allows you to write out a sort of simplified expression so that you can read it sort of as a sentence, as my card is 17 is less than or equal to my card, or my card is less than or equal to 19, so that you can just see that it fits within that range. So I come in here, if I fit within that range, and the dealer shows less than a 5, then I won't hit. I won't get another card because I'm assuming the dealer, as I wrote here, will bust because the dealer in blackjack will have to hit at this point because at best they have 14, which means they're going to hit at that point. Then here, what I'm saying is if I had 17, 18, or 19 and the dealer is showing a 7 or above, this is where you can question the strategy. I'm going to say that you should hit in this scenario so that you have a better chance of beating the dealer. So I have comments in here that lead to my thoughts. The example here is that you start out with an if, which then means everything inside this block and only inside this block is going to then run. And it's going to say, okay, if the dealer has less than 5, immediately return false. So in the scenario where the dealer has 5 or greater, it's going to go to this elif, and it's going to say, okay, now if the dealer is showing greater than or equal to 7, then I'll return. Now what happens inside of here is under the condition that neither this if or this elif are true, it will keep running the code past it. So sort of how I mentioned with this function, the function executes all of the code until it hits an outer indentation level, and then it sort of stops as long as it hasn't hit a return. The same thing is true of these if statements. So this if statement will execute everything that's inside here that is highlighted, but if it never hits a return, it will then hop out the next time it sees an indentation level that's 1 greater and will execute what is there. So that means there are 2 cases in which really 3 cases in which this false will be hit. One case is if my card does not fall within this range. So if my card doesn't fall within this range, I won't execute any of this code because it's 1 indentation level in. So then I will fall to the next set of code that is at the same indentation level as my if statement. So then I'll return false. The other scenario where I return false is if neither of the inner if statements is true, because I will never return a value. So if this isn't true, I don't return here. And if this isn't true, I don't return here. So it will fall back to here. Another way that this code could be written is I could provide I could provide more concrete examples where it has to return on every one of them. But usually if you were to read someone's code that was writing Python all the time, they would not write this because most of those return values are assumed as you're going through it. So you could write it so that no matter what, you always write an if and then an else statement, but it is not actually required. The code will run the same in those scenarios. So this is the should I hit, which logically the way this works, so to talk through the actual function and what it's doing, is I pass it in the dealer's value that they're showing me, which will only be one card, and then I take the value of all my cards added together, because I know all of my cards. And if at any point I have less than or equal to 11, or my cards are equal than, greater than, or equal to 21, I'm going to hit, which that's actually shouldn't be there. That's a bad idea. So I'll hit in this scenario if my card is less than or equal to 11, because no matter what I get, worst case I get 21, best case, well, actually no, best case I get 21, worst case I go up to 12. Which, as you can tell, mean if you read this, so the only scenario where I'm going to potentially hit again is if my cards are between 17 and 19. So if I did end up with 12, my poor strategy would not hit. So related to what we did last time, I just made a little helper function that I gave a bunch of possible values. Sort of tried to make it be evenly distributed how a deck is. We'd have 10, Jack, Queen, King. So your odds of getting a 10-point card would be relatively the same. Really true, because your odds go down a little bit when you do get one of those 10-point cards or any of the others. But I made it simple to get a card. And then I made this other helper function of print who won, so you can know who won at the end of the game. This is what I was talking about for determining who wins. If your cards, if at any point you, the player, instead of the dealer, have more than 21 points, the dealer won, and I busted. And this is a good example of an if, elif, 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 else. You can have pretty much as many elif as you want in a function. And these if statements. So the next one is if the dealer at that point has greater than 21, I won because the dealer busted. If the dealer has a greater value than my cards, then the dealer won. If I have a higher value than the dealer, then I won. And then finally, the only possible case that is left, which is why I have the else, means we tied. Because either I busted or the dealer busted or one of us has more points than the other one. And then I print the message in each one of these. And I don't return anything. So if by default, what happens in a function, I mentioned this last week, by not returning anything here, there's no value if you call it. So if you try to get something from print who won, and this has actually, I think, caused some people problems in submitting programs on Vocarium, if it is expecting you to return a value rather than print, then you should do that. So in this scenario, since I have print everywhere, this function never has a return statement in its body. So you don't get anything whenever you call it. You end up getting none, which was that example I showed last week. Where if you have a function that doesn't have a return value, and it just does a print, and then I go to print a call to that function, none is what gets returned. So in this scenario, if I try to then add and execute that, I get a type error because this function has no return value. So a lot of the assignments in Vocarium will expect you to actually have the function you created return a value, so that what you're doing is you're then just printing one line instead of having what happened just a second ago, where if there is no return, I'll do this first so you can see its output. So the has return returns hi, which is a string, and then it prints hi plus hello, which gives you hi hello. Now when you call no return, what happens is it prints hi. Implicitly, because there's no return statement, it returns none, which is a none type. So we've covered that. If you have none, it's called a none type, which is why in the exception here it says none type and string. It's unsupported to add them together. So when you call no return here, it prints hi because it has a print statement there. But then when it goes to actually call print later on a call to that function, it's really getting none from it. If you call the function. So a call to the function, it returns a type of none type. And now this prints hi inside of it. And it raises this exception because it's trying to add none type and a string together, which is not allowed. The reason I want to reiterate that is because a number of the submission problems that some people have had in all the classes, Rhode Island, St. Louis, have been related to having functions return values versus printing. So keep that in mind whenever you're writing your functions to submit to Vocarium. So this print who1 does not return anything. So if I were to try to use the value that got returned here, it wouldn't have anything in it. So what happens next is I set up the game. I get the dealer showing card, and then I get the values they have. So they'll have another card that's secret. I don't get to know what that is. And then I get dealt 2 cards. And then I determine if I should get hit based on what the dealer is showing and based on my value. And then what I do in this if, so I'm calling the should I hit function that I defined up here. And then within that, so if it says I should hit, what I do is I go and I take my cards and I go and get another card. And this is, I mentioned this last week as well. The plus equals is the same as writing that. So you can take player's card value plus get card is the same as doing plus equals. The advantage of plus equals is you write less. Functionally, it is the same. So then here, this is really just the rule of the game. If the dealer will hit, then they get more cards. So I'll say what the dealer ended with, and then what I ended with, and then we'll print who won. And the reason for these two lines is that hopefully they agree with the who won function. So the dealer won with Aussie, ended up with 12. And if anyone has any questions or anything about this, feel free to shout out. If you want anything explained further on here. So then oh yes. Yeah.
Can you go back to that example we have 17, this is less than value. That syntax is not really covered in Python. That they specifically were showing, they made a little box talking about people doing, they would have said 17, they would have said like my card values or less than 17 or 19 or 20. That's exactly wrong, you know, we think that way, but that is kind of confusing. I haven't seen Python doc that is explaining that.
Explaining how this.
Yeah, that syntax would be, you know, because it's not formal. That's not important. You can't say. Right, go to see they.
So let me get to. So it is covered. This is difficult for me to read. So it does cover it in here, but it's showing you something you don't need. So the other way to write this, if you don't like this, is like that. So you would say, if my card is greater than or equal to 17 and my card is less than or equal to 19, idea to the plus equals down here. It's a way to not necessarily have to write it all out. This is more clear if you're unfamiliar, so I'll actually leave it like this. And you should call me out when something like that is confusing, because I may not remember that it is not obvious or is not covered there. Not doing it on purpose, it's just that I've been writing Python for a while, so I might take shortcuts that are not obvious at first glance, and let me know that, and I will expand it out to what it actually is. And no one doing, quote, professional Python development is going to care either way which one you use. But that is what it would read out to, is if my card is greater than or equal to 17 and less than or equal to 19. And another way to read that, so it might be easier to understand, is if you're saying it's greater than or equal to 17 and it is less than or equal to 19. That is the way that expression reads the other way as well. One way, this way is writing it sort of more of an English prose style. The other way would be more like a mathematical expression that you might write down in a math formula, which that was my background. So in college, I started off as a math teacher, which is why I might, when it comes to the math things, write them as formulas and not as what would be easier to read. And let me know that, because I don't realize I'm doing it. So are there any other questions or anything confusing in these examples? One of the things I wanted to sort of reiterate, is how the indentation matters a lot for how your code executes. So a number of people have sort of had problems and sort of wrestled with different indentation levels, both in submitting answers to Vocarium and having problems there, as well as just running the code in general. And try to keep in mind that the way it will execute is it's always one level indented inside for an if statement and a function. Generically in Python, it's anything that falls after a colon. So this character here, this colon, you are required to always have some expression one level inside of there. So to give another example there, so if I try to write something that is, so I'll say x is equal to 10. So if I say x is less than 11, and then I go x is we'll say 15, and I'd say it's also less than 13, and it's less than 9. So if you notice, nothing was printed because this nesting says, okay, if this were less than 15, I'm going to go in here and run this code. If it's less than 13, I'm going to go and run this code. If it's less than 9, I'll go and run this code. Well, it is not less than 9, so it goes to run code, but there's nothing after it. So another example here. So if you notice, even though this condition fails, it won't print what is in this else, because what happened is we said that x was equal to 10. So 10 is less than 15. So we come in here and we execute this. What that means immediately is that this else, that is at the same indentation level as this if, this code right here, everything inside this else block, will not get executed whenever this if condition is true. Regardless of what happens inside of here, as soon as the if that matches indentation-wise with an else, if the expression inside here is true, your else, what is inside your else, will not get ran. Now, if you wanted a default here, you could say and then what happens is it prints default because it comes in here, x is less than 13, so it goes and executes what's one indentation level over. It checks to see if x is less than 9. It's not, because x is 10. So then it hops out from here. There's no else, so then it hops out an indentation level, and it keeps executing from this indentation level down. So what happens now is it hits print, which is why you see the default here. So the same is true if you want to say regardless of what x is, super default is always going to happen. So if I go and say x is 20, this if is false, so it's going to hit the else, which makes it print by, and then super default, because no matter how this all turns out, because there's no return statements here, so a return automatically makes you leave wherever you're currently executing and go back. These are just print statements, so what's going to happen here is this else happens, everything in the else gets exhausted because there's nothing else in here, and then it hops out the indentation level, and print super default happens. If I go and make this 8, it'll come in here. It'll actually hit all of the scenarios. So the way that this executes is it comes in, it says 8 is less than 15, so I'll come inside this block. Then it says, okay, x8 is less than 13, so I come in here. Then it says, oh, 8 is less than 9, so I come in here and I print hello. And then it comes down, there's nothing else inside here, so it hops out. One indentation level to here, equal with that if, but there's nothing there, so it hops out another indentation level, and it hits this print, and that's why you get the default. And because this was true, it skips over the else and everything inside of its executing area, and then it falls to the same indentation level as the if, and says, okay, print super default. So the takeaway here is that the way that you indent has a very large impact on how your code executes, and it matters a lot whenever you start to use if statements, because the only thing that will get executed within an if statement is what is indented one level underneath that if statement.
So something like that at work?
This specifically, I would not write this one in particular because there's nothing happening. Now, if I specifically had something here and for some reason I needed to do this, then I may do that. It's less than 15.
You don't have those, let's say they come there, because you don't need them, just the nature of Python.
Yes, so so that was sort of why I had the example up here in this should I hit, where I didn't provide very many else statements, because when you have a return, that will always stop running. So in this example here where I print these, I know that no matter what, as long as I have a number that's less than 15, I'm going to print this out. And in regular programming, that would be, well, regular. So if you were to program day to day, it is very common in Python and other languages to not always include an else if it is guaranteed to be the default.
But Python is the only language I know of that allows you to do representation. The other language with else's in there, all those two else's, have to have else's because they have to match up with that bottom else. Because it's Python, it's unique in that regard, and that's why it's more needed. I'd rather have else's underneath those ifs and have a no operation just as it's not in place. I would say you can do that another thing.
So the
Every language, I know of, does allow you to do that. You can do that in JavaScript.
so the
I know you can. That else down there, that is.
so the can
The inner if would have been matched up with something else.
so the confusion here is why did I not always provide?
I don't know if there's a no operation thing. Like, I have here as well.
Yeah, so you could put pass. That means it won't do anything. So the question was, why did I not put else statements here? That so you could tell obviously what was going to execute each time. And that was one, because Python does not require it. Depending on other languages that you use, it may or may not be required to have an else condition with your if. So for example, the first language I learned to program in, I believe, was Ada 95. And it, I do believe, required else conditions anytime you had an if. So here I would have to say something, I would have to do something. So I could print an empty string, for example, with what we have. Other languages, usually dynamic languages, similar to Python. So Python is what's called a dynamic language because it allows you to just sort of declare and run things. So on that first day, whenever we talked about what Python does, is it takes some code you write, runs it through this thing called an interpreter, and then gives you output. Other languages have an extra step in there that's called compiling. So it would take your code, compile it, and then it would become machine code, and then your machine code then gets executed on whatever computer you have. The thing that is unique to Python and other languages is you don't have a step where your code is compiled to another, basically another language. So Python, you could write your code and say English, and then the computer reads it as English. Other languages, you would write your code in English, and then it would translate it to whatever language that machine spoke. So if that language spoke French, it would execute that code in French. So you wouldn't actually necessarily be able to read your code in other languages. So what was your name? I did not catch your name. The point of this being, in other languages, the else may be required in what you're writing. In Python, it is not required. JavaScript, which we'll learn in the second unit, the else is also not required, provided your syntax is correct. Similar to Python, you don't have to have anything other than indentation. Other languages require extra characters to tell the program where the code is. That's why I like Python. You don't have to provide those extra characters. It just reads the white space and it knows. So is there any other questions around what I've covered so far? Or statements, or just like, I see a hand. So the question in Python is, can your indentation be tabs or spaces? And for anyone who is curious, what that is represented in the computer as, so you can have that character, or you can have this character, which look identical. Oh, I did a new line, I mean that, I meant T. So in here, there are two characters that appear to be the same. To make that a little easier to read. So the question was, is it tabs or spaces? So PEP8, what I linked to last week, specifically says to always use spaces at each indentation level, specifically to use for. Use here. However, it does not technically matter as long as you have only tabs or only spaces. and it has to be the same number of them per indentation level. So like if I go here and I change that to be 2, notice it's red, which is what I'm programming in highlights to tell me it's syntactically broken. But this will also say indentation error. Unindent does not match any other indentation level, which is an error some people have gotten in submitting to Vocarium. What that means is somewhere in your code, it's not in line with what is expected. So I could change it to be 2 spaces per indentation level, or 1 space, or 1 tab, or 2 tabs, but every level of indentation in your program has to match. So here there are 4 spaces. So then if I go to here, that has to be 4 and 4, it has to be 8 spaces. So then this would have to be 12 spaces. But whenever I'm writing code, as you can see, I'm not hitting my space bar 4 times, I'm hitting tab. So the tab character, which is right above your caps lock key, is right next to your Q on the keyboard. As long as you just use that whenever you go to write a line of code. So if I were to go here and say, what I'm programming in automatically drops me down a level of indentation, but say I wanted to go, I just hit tab here, and it automatically tabs me in those 4 spaces. Depending on what you're using to write your code, it may be an actual tab character, but that is not important for now. It doesn't really matter. But if you do see, so for example, this breaks because it goes and it's not, you can't just randomly indent your code because there's nothing here stating that I have code that needs to run inside of something. So there's no if statement or function here. There's no if or function declaration, which is why it says there's an indentation error unexpected indent. Now if I remove that back and run it, it'll run correctly. But the main question being tabs versus spaces. The way that it will look on your screen may be different. That is all in how your computer is configured. The difference between a tab and a space is a space will always take up one spot. So it'll always take up the same width as like in any other normal letter. A tab is special. So if you ever use a typewriter, it comes from having a tab and a typewriter that would push you over, I think it was an inch. So with a computer though, it may not always be an inch. It's whatever your computer is configured to. So your computer may say all tabs are 1/2 inch or 1/4 inch whenever you use them. Which is why things like style guides say to use spaces, is so that the code reads the same on everyone's computer. Because if you use tabs, it may look different on someone else's computer. Especially if you use multiple tabs. Because if you notice here, 2 tabs, 3 tabs versus 3 spaces is a lot further out. So that's where tabs versus spaces, it doesn't matter as long as you only use spaces or you only use tabs. It won't matter in Python. But when it comes to reading someone else's code or what gets output, it can be harder to read using tabs. So, if there are no other questions, we get started on tonight's studio. I assume. I don't see other hands. Is there? No? No? All right. So studio searching. You pull this up on your computer. So the walkthrough is to write a function that if anything in the list you give it is true, then it returns true. So, which it gives you. So we print it. Oh, I broke it. Oh, because there's an extra O. That's a typo. So it returns true because in this list there was one true. Now the studio is to write a function that takes two arguments, which the first argument is a list of numbers. They can be integers, floats, can be a mix of them, so that means you could write something that's numbers 1.0, 200, 15.3, saying if you have a list of numbers, you want to be able to say contains n my list of numbers. So list of numbers, see if it contains the number 1. And if it contains that number, then what you run should return true. So the goal here is to write a function that, given a list of any numbers, if you pass another value in that says, you pass a value, it will return true if that number is in the list that you gave it. And give you about 25 minutes or so to work on this in your groups, and feel free to expand on it if you want to. And then what I'm going to do a little bit differently today than what I have done based on some feedback I've been getting is please do message me on Slack if you want me to show your solution. And I'll talk through your solution and show everyone. But I'm not going to have necessarily people come up and explain it, because there has been some confusion in the varying explanations that have happened. So based on feedback I've gotten, I'm going to be the one that talks through the code examples to sort of try and keep, and if I'm not doing a good job of it, you should tell me. No one has told me I'm doing a bad job of talking through code examples, but you can tell me if I'm doing a bad job. Or if I'm covering too much or anything that's too complex. Like last week, there's a question.
In that example, let's say you had 1.0 as a float and you want to check if 1 wasn't there, would you return a true or false?
So the question was, since 1.0 is a float and 1 is an integer, do you want to return true or false in that case? And I actually, if you could create two functions, one that returns true whenever it is what you'd call semantically equal, 1.0 semantically is equal to 1 because they're the same integer value. But I would also, if you didn't mind, writing a contains in you call it contains in matching type. Which would say that if you're given 1.0 and 1, it would return false. Because 1 is 1 and is an integer, and 1.0 is 1.0 and is a float. So if we could write both of these functions so that in the one scenario it returns true because they're both 1, but in the other scenario it returns false because their types are not the same. So we could write both those functions. That was part of the expansion. That's what people would do. But these instructions, I'll leave this page open on the YouTube live link that I put in the Slack channel. So you can read it here. It's also on your in your book. You should be able to reach it from the class link for today, the studio. But feel free to get started.
For Doug that runs the Sprint Accelerator, you want your email and cell phone number?
Yeah,
Before you do I'm going to do an email introduction for you too, and then he'll get you one of these things.
My handwriting is terrible.
I know I have your email somewhere.
I think I was only actually on one email with you.
I think that, yeah, Anna sent some sort of connection. Yeah. I'm much more in the dark on this class than I was the last one. I'm trying to figure out how bad that is. I'm not sure. I'm like, what am I not being helpful on? Okay.
I think we were equally in the dark for some things.
Huh?
I think we were equally in the dark for some things.
I mean, you are approaching it differently than the other, than the last class, but the content is different also. So, I
Right,
think
and that's the other
actually-
thing I am not certain on at all, is how to approach.
And I think it's sort of an unknown
What to
because
do.
it's only been done once. So,
And that's what
and
I,
I think that it'll help if we can get those specific things to work for the back. I was asking about that, and she said they have to have an outside AV guy because they can't figure it out. She thinks it's been scheduled, but she'll check again tomorrow. Yeah, that'd be good.
because I don't necessarily, like, I don't know because another route is I could like walk around and talk through it, but I don't know if I want my laptop on me and broadcast, because I don't know of a good way to show the concepts that doesn't involve showing us there. But when I mentioned to Zach, I was like, well, which one seems preferable to most people that take the class? Would prefer PowerPoints where I just show something and talk through that and leave it there, or show something live? Any specific reason the live kind of worked out better because they can see you make mistakes and see how you fix them.
I mean, and I think it's one of those things too. If you had a PowerPoint or notes like that, I mean, you can always post that on, like, the stuff that they can reference when they're trying to do their own work at home and
Right.
getting hung up on it.
And that's why I all of the things I cover in class on these,
There you
all of
go.
this, I publish all of this out on my GitHub and I link to it from within the class on campus.
You mentioned that last week. Can't give a way to see if people are going to that. Is it trackable at all?
Oh, it is actually trackable. I could check that
Interesting
now.
just to see, like, are people using that tool, and if not, how many reminders does it take? Because I think that's a big part of it too. I think people sometimes, what we saw last time is people got overwhelmed by the tools.
Which is why I tried to not tell them it was on GitHub.
Yeah.
And some people were like, oh, it's on GitHub. And I think something that is actually
Yeah.
feedback I have for Zach is I think it is the diversity of skill level is bad
Yes, so crap.
because it.
Hello? Okay, I like the regular turtleneck. That's the better one. Okay, cool. Well, I'll check it out.
Ooh. Oh, there we go.
That's why you like it so much. I know, it's just like you can't take a joke, but yeah.
Oh, right. That's what. Yeah.
We're
That's awesome.
And I may be dumb, and maybe I thought I saw that, and maybe I just misread what's on here.
So basically,
Yeah, it's just the
she's
class.
saying
So it's
people-
basically pass fail on this class one. That is the attendance.
Classic.
Oh, now I'm just
Good job.
confused.
I need to get an ammonia one.
Yes.
I should probably get an ammonia one.
Just don't worry about it. Teaching fellows, I mentioned something about grading in-class work. Just don't worry about that. Yeah, that was a misstep on my part.
My mother needs to let me know there's a sale on turtlenecks. Literally. It's like, Mom, people with double chins don't wear turtlenecks. Anyway, I'll pray.
Lots of my wife refuses to wear turtlenecks. She was very self-conscious about
Yes,
her job.
exactly. And I used to love them, but I was like, yeah, I was also 40 pounds lighter.
Yeah, so GitHub actually, it's a feature they released a little bit ago. You can actually see, so for all the content, you can see individually what's been popular.
Okay.
And then directly to the page has been logo. Like this one, which was the in-class, the 27th. So 16 people went and looked at it.
Okay.
So,
Really, those numbers are fairly low. I really don't would that be what you'd expect with, I don't know, there's like 80 people in there now?
it's what I would expect for if people like went back and looked at it. It's the only reason why I looked at it is if you didn't get something in class or you wanted
That's
to.
true. It's not like it's pre.
Right.
You don't look at it beforehand. It's only after the fact.
I'm actually somewhat surprised that number is not like 5
Okay.
because just keep doing it. It'll come back. Aww. Oh, where'd it go though?
Okay.
I lost it. Oh, there it is.
If you need anything, I'll send an introduction email to Gary or to Doug. And then he'll connect with these things. So he will, by next week, he can get you one. I think on Thursday, Zach's boss or Zach's counter person is in town, I think. He's going to come to class. He's the curriculum guy.
Is that Chris?
Yeah, Chris Bay. I think he's coming to class Thursday. He's going to be in town.
So I think the main feedback I have for the next time this is done is don't allow as wide a range of skill levels. Because for some people, what I was doing was like they wanted to cut their eyes out. For other people, it's useful because they don't have that knowledge of the person. I understand that Reggie got frustrated as well. It's like, I want to show my frustration that you're pointing out things that are factually incorrect.
That was where it's last time. Like the something instructor was a big game. Is that what you're talking about? Like people would do that, try to call you out on stuff that's wrong, showing how much they know.
Well, so like the one thing I clearly said that was wrong. I just read that wrong, which is why the code told me I was wrong too.
Which is what you should allow them to have. Let the code show it, and you can problem solve like they will problem solve.
Right, and then the part was around like the else, like you have to have an else. It's like, and I'm only like 50% sure the first language I programmed required what he was saying. No other language I used is required, which is why it's like I don't want to argue with you.
Yeah.
This is not the setting for that.
And that's what you mentioned now. But in the last class at UPC, there were those guys too, and then the people that were beginners were posting on Slack like this is bullshit. Let the guy talk, and So it's like stump the instructor, show you how much I know. Cut it out.
Well, I didn't want to be mean.
Yeah.
So I just chose.
We'll talk offline. Kind of, it's one of those like you say, we'll talk offline.
I wrote it down on the table and then normally they message me whoever the fellow is. Oh, okay.
I didn't realize, well, like this one between.
Which normally people do, or someone just mentioned like,
Oh, yeah.
Mario? What was his name? Oh no, give me my cursor. Where's my cursor?
No, if you want to take a picture of that and get it entered in later.
Yeah, if you don't mind entering. And then, have you entered any attendance in yet?
Yeah, just one person so far.
Because when you
That one that
go,
showed up late, Tom Street.
when you go to the grades, you can actually, I don't know if you know, you can select on the top right, and you can switch to the group fellow group.
Missed on there was, that was on there at the start of the class. It's Vicarian as a student, so I was like able to submit and stuff. I don't know if something's changed. I'm able to, I think I'm missing like a switch to student view somewhere or something.
Oh, you have, so to switch to student view, you probably still have this. You have to go down to settings. And then click student view. That's the only way I know how to get to student
Okay.
view.
And it just seems like it disappeared over there on that. And now you're in it?
I didn't click it.
Oh, okay.
But if you are in student view, it does, it shows us the,
It gives you the test Vicarian account?
yeah. So then it gives you whatever test user this is, and you have to specifically, it shows you down at the bottom if you're in the student view. So
I didn't even notice that.
you don't know unless you work at the bottom, which I almost opened class last week sometime in the student view, which meant I wouldn't have been able to do stuff, and I was confused, and I saw it at the bottom, like, keeps track that you're in the student view even after you leave. Perfect. I was very confused. Yes.
Do you want them to, how do they give you the examples in Slack? Is it like a channel or are they messaging you?
They can just message it to me. They don't have to if they don't want to.
Yeah. Or it's starting to make sense. Really, maybe hoping that's I get 280.
It's a fast solution. I understand.
No, it does. No, it's wrong. Yeah, there's a certain number of digits that accurately. I'm not sure what the time is. It'll start to break down. Yeah, it is. Yeah, it's like and in that case, a lot of times do is subtract one by the other. And yeah, that's why you get around it.
So right now, so we'll tell you the temperature there, and that would be hot.
Yeah.
Oh, no, I didn't. I just said.
It seems so worth it.
That's really. I guess data is always.
Yeah, but I guess it would be what's new too.
You show this.
Okay. And then they're like telling all these like interesting things over here, like I named 2 turtles, right? So I'm really excited. And I just did. What's this?
Well,
That's good.
I'll show you a credit. Yeah, probably.
Oh, that's pretty good.
So, and the format is just expression.
I guess it's just yeah, that. I got that. On the way out. Take one more step. This is great.
There's a couple other than Charts Advanced, another problem. I didn't use that one. There's a couple other. I like Charts Advanced.
So general rule is this.
That's the most common.
Ooh. Awesome. I like it. Nah. Ooh.
I asked her how long was it going to take. I think it's very simple on it. I was literally just a couple lines of code.
Alrighty, we'll start covering some of the solutions people sent to me. This one, I actually received a number of them, so I'm not going to go over all of the ones I received. I'm going to show this one because it's a fairly complete example that's only using things we've learned so far in class. A number of people cheated, I would say, and used some features of the language we have not yet covered. It's all right to use those features, though. You can read about them, get further along. It's totally fine. But I do prefer to show examples to everyone that are what we have covered so far in class. I am going to show one of those examples that's using a feature of the language we have not covered directly yet because there is some confusion as to why. Where's my cursor? There's some confusion as to how this in. So this in operator works. So I'm going to talk a little bit more about that in the next example. This first example does a good job of using what we've covered in class so far, which comes from, make sure I read your name correctly, Damian Barnes. Thank you for sending this, Damian. Where's Damian? So I can associate a face. So, sort of talk through this. Contains in, you pass in numbers, and then in, which is the number. So what happens here? You'll come in and you'll say for each num in the numbers that you passed in, if one of those numbers is equal to n, so you could say, so one of the things that I often care about when writing code, and this isn't a diss or anything against anyone else's code, but is to try and use variable names that clearly convey what it is you're using. So this would read, for number in my list of numbers, if that number is equal to the test number that I passed in, then return true. And what happens, it'll go, so the first time it'll come through, so for instance, say I had some temporary temp. I'll just call it temp, so I can't spell right now. So if I had this list and I pass it in, and then I had some number, say 10, and I was running this, the first time it would execute, it would go and say number in the list of numbers. So on the first execution of this list, what ends up happening is it basically gets a number is equal to 0 because it's the first thing in this list that's passed in. And then on the second execution, it'll end up saying number is equal to 1. So let me change these. So then on the third time, it kind of gets an invisible number equals 5. On the fourth time, I wanted to zoom in so it could be a little easier to read. On the fourth time, it gets an invisible number equals 3. And then on the fifth time, it gets a number equal to 10. So on each of the executions, this is what happens if I pass this temp list as my list of numbers. It'll say for number in the list of numbers that I gave it, which would be this list of numbers. The first time I go through, I would say, does 0 equal the test number that I passed in? So I have test number here, which would have been some number. So I would say the first time through, it goes through the for loop, it's going to say, does 0 equal 10? It does not, so it's going to go through again. And it's going to say, does 1 equal 10? It's going to go through again and then say, does 5 equal 10? It'll go through again. Does 3 equal 10? Still doesn't come true. And then it will say, does 10 equal 10, which is true. So then what happens is it will then return true. Now, if I were to say pass 11, what happens here is it goes through this for loop, goes over each one of these numbers. This condition is never true. So then it falls out to the next indentation level where it hits a different return, and that returns false. So that is the contains in function. Now, this is the bonus. So we had mentioned contains in, which will test if the past, call it test number, is equal to a value inside the list of numbers. I'm doing a little backticks there just so you know that it is in reference to the parameters that get passed into the function. So what is different with the contains type in is it tests if the passed in number is equal to a value inside of the list of numbers, as well as the values type. So every object, everything in Python has a value and a type. So temp, its value is this list of 1, 0, 1, 5, 3, 10. Its type is list. It's a type. The type of some number here is int. It is an integer. So every variable you create in Python has a type and a value. So what this function does is it says, same as the other one, goes through each one of the numbers, and it says if the number is equal to n and their types are the same, then return true, else overall return false. This next one counts how many are in there, so it counts the number of times the value occurs. So initially the count gets set to 0 because you don't know how many are there. And then you go through each one of the numbers, and if it's in there, you increment the count by 1, which in Python you have to do this. If you have used other programming languages, there is a different way to increment a value by 1. Python does not allow that syntax because it does not want to allow potential confusion. So you are only allowed to add in that way if you want to increment by 1 to some value. And then the same function for your type of numbers, same condition as before for determining the type. It checks that the numbers are equal and their types are equal. So then what we get here is we check contains in. So we'll have this list and we'll check for 6. Next up, you check the type to see if the type is in there, number of times that value appears in the list, and the number of times that value and type appear in the list. So as you likely expected, 6 isn't in here, so it returned false. 5 is in here, so it returned true. 9 is in here 2 times, so it returned 2. And then in this one, 10 is in there 1 time and has the type of the same, which is 1. So sort of showing how this would be different in this scenario. Now it is 0 because 10.0 does not share the same type as 10. Because if we print the type of 10 and we print the type of 10.0, we get an int versus a float. And the sort of the big reason ints and floats matter on a computer is that if you're doing some kind of financial accounting or some system that might give you your paycheck and do a direct deposit into your account, computers are bad at what's called floating point arithmetic. If you've seen the movie Office Space, the person slowly steals money out of the account because he does the rounding. That's an actual thing that happens with computers. So depending on how advanced your computer is determines essentially how accurate it can be with those values. So a lot of the times, depending on the system you're using, it may use integers all the time and then just multiply by 100 or 1,000 or divide by 100 or divide by 1,000 so that it doesn't lose any precision. Because when you work with floats, you can lose, if you remember back to your last time you took chemistry, which you probably were not very excited, the precision is basically how far out, how many decimal points you can go out. So the main reason you would care between an int and a float is you can get more specific with a float, but you risk, at the risk if you're creating an accounting system, which is really the only time you care that much, that's when you'd have to be careful about how precise you're being on your numbers so that you don't lose fractions of money. So what a lot of systems will do is instead of doing something like this, where you have 10, they'll just always use 100 and know that the last 2 decimals are cents, for instance, so that you never end up with a fractional amount in your system. But that's why you might care over here when you're doing the work to check the type with your number. And the other example I wanted to show that uses what we've covered, uses an operator. Oh, that's not supposed to be there. I wonder if that would run. Then if I do this, my numbers that I passed in, we'll say it contains a 4.5. We get false. So what is different about this one compared to the others that we have used? So actually, I'm going to delete this because we have not covered that at all. I'll create another function here. So you can then get the count as well. So we can print that and then the count, number of times. So initially in the first few examples that I typed, I was always typing out examples just hard coding the values. Something that is nice about being able to write the Python code directly like this is that you can just keep changing this value. So we know 4.5 is not in there, and this is where this operator is different, so in. If you notice up here, we used it with 4. So when you use for some value in a list, you iterate over that list, and each time you go over it, like I mentioned up here, the first time you get the first item, the second time you get the second item. When you use in inside of a Boolean expression, so inside these if statements, so when you want to check that something is true or false, in is special in that it will say, is the thing on the left inside the thing on the right? So you can do that with any list. So this could actually, this whole function here, because that's what this does, can be reduced to that, because you're saying is in inside the numbers I passed in. And this is where so what in does is it compares both type and value. So it compares both automatically. So in is the same as using this contains type in. Make sure. So then if I go and I change this guy to, say, value 2 is equal to 4. I then get true because 4 is in the list as both an integer and the number 4. If I go and change this to 5.0, same thing. Ooh, someone is asking what the syntax is to always show the number of decimals, and that we will actually cover in about 5 weeks. So I'm not going to cover it now. But if you want to look ahead, it's covered in the string chapter that we're going to use later. In order to show a certain number of decimals, you'll have to do you'll have to change what it is in order to represent it on the screen how you want to show it. Are there any questions about how this works? Is the way in works when you use it as a Boolean expression. So whenever it is used within an if condition, it's the same as what this function is doing. It goes over each thing in your list and it says, are the values the same and are the types the same? Yes.
When I tested mine like that, I thought it did test the type. Can you do that example? Like value 2 equals 5, can you try that?
So here. I'll try it. That's going to be a careful search. So whenever I lead you astray a second time for the day, sorry that my searching is poor. I have to make that smaller. So what he just pointed out is that I've been lying to you about how in works. It does not care about type. It only cares about value. That's what I wanted. So membership test operations is what in does. So this is where you can always know what the actual truth is, opposed to what I tell you the truth is. So I'll put the link. It'll be on here for later as well, so you can look at it if you want. So what he just mentioned is, if you notice you have 4.0 and 4, it returns true because it is value equals. And if you read through this whole big deal, is it just evaluates to true if X is a member of S. So if X is inside a list and otherwise it's false. And it specifically says, it gives other caveats on how it works with different data types. So we've used lists. So the data types that we've used so far are lists, strings, integers, and floats. And and we've used some strings. This documentation explains how this operator, which is called in, is the same idea as having a plus or minus or division, just another way to have something happen between two variables. So it also explains in here that it does not care about the type. It only cares about the values whenever it is comparing the base types, which would be integers and floats for Python. Other languages may care differently. Something that I did here to sort of make this easier to read, whenever you have parentheses in Python, you are then allowed to indent and have it on multiple lines so you can easily read it. So when you call the print statement, if you don't want to have to chain 10 things in a row, you can rewrite it so that it might be easier to read, so you don't have to rewrite a bunch of things. So it can be easier to read. So on this scenario, helps if you do not typo. And what it's pointing out here is I'm missing a comma. So then it prints true, 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 true. So this makes it print on the same line. You go here and do what some of what has been needed actually for the Vocarium assignments is specifically throwing a new line in there. And the reason that is slightly indented is whenever you pass things into print, it automatically adds a space to the next thing so they get printed continuously. But that is all we have to cover for the evening, unless anyone has questions. All right, thanks for coming. Everybody have a good evening. And please give me feedback if I'm presenting poorly or something is not clear. I want to improve the class as best as possible. You can message me directly. You can email Zach and tell him I'm terrible, and then Zach can tell me I'm